Now, in this video, we are going to take up one more Python program, how to check whether the entered number is prime number or not. Now, first is, I will going to give the input. So what is the input? I will enter one number. If that number is prime or not, we want to check. So how many input I will going to get? I will going to get one input. So what is the nature of the input? It should be an integer value. So num is equal to int input, enter a number. By default, always in Python, whenever you give the input, it will be considered as a string. So then you have to use the function to convert that into whatever type you want. It may be an integer or it may be a float number I want to convert. Since I want to convert the entered number, which is a string, into an integer, so I'm saying as int input, enter a number. So we have given num is equal to 1. So what is the output we will going to get? Now enter a number, it is equal to 1. Then what I want, if the entered number is equal to 1, means what? Is num is equal to 1. Is 1 is equal to 1? Yes. Condition is true. So print num is not a prime number. So what is the output? 1 is equal to 1, condition is true. So 1 is not a prime number. It will go to print that value. So in this case, 1 is not a prime number. Next, output. So we have enter a number 5. Next one. So num is equal to 5. Is 5 is equal to 1? Condition is false. If 5 is equal to 1, condition is false. Therefore, it will go and skip this statement. If it is true, then only it will go and execute. Like if it is 1 is equal to 1, if the condition is true, so num is the variable name, 1 is not a prime number. So that is the reason why you are getting 1 is not a prime number. Now, next what I need to do, I want to check whether the given number is greater than 1. Yes, is if num is greater than 1, means what? Is 5 is greater than 1. So condition is true. Once if this condition is true, then what I want to do, I want to check. Now how to check that? First of all, what is a prime number? The prime number is 1, wherein a number is divisible by itself and only by 1. If both the condition is true, then only it will be a prime number. Otherwise, it becomes not a prime number. So what I need to do now, 5 should be divided by 1, 5 should be divided by 2, 5 should be divided by 3, 5 should be divided by 4. By checking in all these things, if in all these conditions, if you don't get any remainder, that means if the remainder becomes 0, then the number entered is not a prime number. So the number entered is not a prime number. So here for I in range 2, num. What is that num? Num is nothing but 5. So 2, 5. That is the value of I. Iteration. So if 2, 5 means what? It is in the range of 2, 5. That means 2, 3 and 4. It is excluding the end number. So 2, 3, 4 I want to check. So what it says, if num percentage I is equal to 0, means what? If I divide a number by an iterated value, like in this case 5%, 2. If you divide that, if you are able to get a remainder is equal to 0. Now in this case, the remainder is not equal to 0 because the remainder is equal to 1. Why? 5 divided by 2 means what? 2 2s are 4, 5 minus 4 is equal to 1 is the remainder. So that becomes false. So if that becomes false, then it won't execute this. Again it goes back and takes the increment. What is that increment? 2 plus 1 is equal to 3. So now you are 3, I is equal to 3. What is num? Num is equal to 5. If you divide 5 divided by 3, 3 ones are 3, 5 minus 3 is equal to 2. So the remainder becomes 2. But what the condition says? The condition says that it is equal to 0. If the remainder is equal to 0 means That means it will be exactly divisible by the number. Whatever the number you see, if you divide that, if the remainder gets 0, then it is not a prime number. So again, it goes back and takes the iterated value. I is equal to 4 plus 1, it becomes 5. Suppose if you are considering for I is equal to 3 plus 1, we have not done that. 4 is less than 5, condition is true. Sorry, the condition is false. Sorry, 4 is less than 5, the condition is true. Then what happens? I is equal to 4, it will going to take. Num percentage I means what? Num is 5, percent 4, the remainder is 1. So it is not equal to 0. So remainder becomes 1 in this case. So again it becomes false because the remainder should be 0. Since the remainder is not equal to 0, again it goes back and takes the increment. I is equal to 4 plus 1 is equal to 5. Is 5 is less than 5. Condition becomes false here. Since the condition becomes false, okay, it will not going to come to this statement. Instead, it comes to this. So what is else? Else will be equal to print num is a prime number. Since the 5 is not divisible by 2, 3, 4, so naturally, since that conditions becomes false, so num which is the prime number. That means 5 is a prime number. This is how you will be able to execute the program. Now we will try to explain this or try to do this by using coding. So how to do that? Num equals int input, enter a number. Enter a number. Then if num is equal to 1, if num equals 1, then what is the condition says? Print num is not a prime number. Okay, num is not a prime number. Then if num is greater than 1, if num is greater than 1, then for I in range, what is that? 2 comma L, 2 comma num, 2 comma num. Then if num percent I is equal to 0, if num percent I is equal to 0, then what it should do? Print num is not a prime number. If it is equal to 0, then your program has to be terminated. Break. Else print num is a prime number. Num is a prime number. Please try to check whether how it will go to work now. I will do this. So I will enter a number. I will say 1 is not a prime number. Now I will go to this. I will try to enter 2 now. What will happen? Let us see. 2 is a prime number. Of course, in this case, 2 by itself is a prime number because once it executes this, 2 is greater than 1, condition is true. It enters into this for I enter range 2 comma num. So how exactly it will going to behave? Let us see now. If I try to work with this debug Python program, suppose if I say the value of the number is 2. 2 is equal to 1, condition is false. 2 is greater than 1, condition is true. 2 comma 2, it won't execute this at all, comes to this directly. So num is a prime number. So 2 is a prime number. So next what happens? We will going to take up the third one. So I will consider this I will enter the num value. I will go to take 5. Okay. Is 5 is equal to 1? Condition is false. Is 5 is greater than 1? Condition is true. 2 comma. So now if you observe here is 2 comma 5. So initializes the value of I is equal to 2. 5% I, 5% 2 is equal to 0. No. Again it goes back and takes the increment. Num becomes 4. You can see, sorry, I becomes 3. So 5% I is equal to 0. No. Again it goes back and takes the increment. What is that? I plus 1 becomes 4. 3 plus 1 becomes 4. Then 5% 4 is equal to 0. No. Condition is false. So since the condition is false, it again goes back and takes the value of the increment as 4 plus 1 5. 5 is less than 5. No. Condition is false. So print the num is a prime number. Now say for example, I will consider one more. I will consider 10. See what happens. Enter a number 10. Okay, enter. Is 10 is equal to 1? Condition is false. 10 is greater than 1? Condition is true. 2 comma 10. So initializes the value of 2 is equal to I is equal to 2. 10% I is equal to 0. Yes. So it comes into this. Then 10 is not a prime number. So 10 is not a prime number. So once it in any one of the condition, because if I say 2 comma 10, it will start from 2, then it iterates to 3, 4, 5, 6, 7, 8, 9. So I have to perform all these 9 operations and then you have to say whether it is prime or not. Correct? So if any one of these times, if the remainder becomes 0, then it is not a prime number. So the prime number is the one wherein it divisible by, so when the number is divisible by itself and 1, then only it is called as a prime number. Other than these two, in none of the numbers it will be divisible. So in other words, if any one of these condition in any one of these iterations, if that condition becomes 0, then it is not a prime number. So automatically, since you have a break, it will going to break the statement and comes out of the loop. So this is how it will going to work for a prime number by using Python program. So this is the advantage. Suppose if I don't give this break here, see what happens. I will go to this. Again, we are going to try to check. So I will go to enter a number. I will go to take 6. Then 6 is equal to 1. No, 6 is greater than 1. So 2. So I will do 6 divided by 2 is equal to 0. No, num is a prime number. Again, it goes back. Okay. Again, it goes back. It checks 3. 6 divided by 3 is equal to 0. So 6 is not a prime number. Then again it goes back and takes the value of 4. Now it goes to 5. It is not equal to 0. Again it goes back. So now here it says 6 is a prime number. Why it is telling 6 is a prime number here and 6 is not a prime number here? Because in every time it goes and checks. If it is divisible, then it is not a prime number. If it is not divisible, then it becomes a prime number. So that is the reason why we have to give a break statement here. If you don't give the break statement, then your program will going to become wrong. So this is how we will be. So we should know how to write the correct code. That is very, very important. In this condition, if I try to enter, in this case, if I try to enter the value of 6, 6 is not a prime number, obviously, because once you go to the 2, 6 divided by 2 is equal to 0. Yes, the condition is true. So therefore, it will execute this. 6 is not a prime number. Since we have a break statement, it will break the loop itself and it comes out of the program. So this is how you will be able to find or to check whether the entered number is a prime or not. Thank you.